Hello, everyone, and thank you for rejoining us. If you have been with us the last days, welcome to everyone who hasn't joined us the other days to this week's Dairy Technology Week with the Institution of Agriculture Engineers. I am Daniel Heft. I am the chair of the Engineering for Food and Drinks Special Interest Group. I studied food engineering myself in Germany, did a master's in Reading as well in food technology. Worked for a couple of years in the food manufacturing sector, and today's event day is sponsored by GEA. We will have two people presenting. First one up will be David Simmons, Head of Sales at GEA Farm Technologies, followed by Daniel Bussmann, Head of Process Technology, Beverage and Dairy at GEA Group. And I am accompanied today by Charlie Nicklin, our CEO, who will take over the moderation. If you want to ask any questions, we would like to ask you to make use of the chat box in Zoom, and then we will handle it from there. Over to you, Charlie.
Okay, thank you, Daniel. So I'll make the introduction and we'll crack on. So David Simmons, David was born and bred on a dairy farm. He completed a National Certificate of Agriculture at Bicton. He spent a bit of time overseas in New Zealand managing a dairy farm. Joined GEA in 2005 as a sales manager and now supports the equipment and hygiene sales team. So David's going to talk about milking equipment. So over to you, David.
Okay, brilliant. Okay, so as Charlie said, my name is David Simmons. I'll jump straight into it. What I have done, I wasn't quite sure how to target the audience here, so I have plagiarized a few of my colleagues' presentations and put one together, and hope it suits everybody's needs here. So just bear with me. Okay, so I work for GEA, and I'll talk a little bit about that more in a moment. I'll do a quick overview, and then obviously, as Charlie pointed out, I was a sales manager and I'm a very keen salesperson, and I love to talk about our products, but I thought it'd be worth talking about how a cow gets milked to start with. Doesn't matter which manufacturer it is. So I'll talk about the milking philosophy. I'll also do a short bit on the MEA presentation I pinched off an MEA colleague, which is the Milking Equipment Association, and then I'll start talking about GEA Farm Technologies and what we do. So just a tiny bit about GEA. And I'll just quickly go through this. If you have eat a chicken nugget, it's probably a third of all those chicken nuggets have come out of a GEA product. So we are a huge processing company. If you have coffee, there's a 50% chance it's come from a GEA product. If you have a pint of beer, again, 50% chance it's come through a GEA product, and so forth, even to container ships where the separators clean the oil for them and stuff like that. But my interests lie with the milking of cows, so I will jump onto this. That was me not last year, that was me 40 years ago, milking cows in New Zealand. Over there, when I was over there 40 years ago, there wasn't a single cow on the South Island. Now all the milking is done on the South Island. Just out of interest, when you milk the cows, every milking you used to drench the cows because of the protein in the clover and the grass, and they would get bloat. So you used to drench them every morning to stop them getting bloat. And you'd put your hand on the cow's nose and it'd just pick up its head and open its mouth, and you would just drench it. So that was my year in New Zealand. Very, very interesting. Okay, the principles of milking a cow or a water buffalo or a sheep or a goat or a camel, or whatever you want to milk, are all very, very similar. If I talk about water buffalo, they don't like letting their milk down and need more oxytocin, but generally it's all very similar. And whether you're milking your cows on a 72-point Dairy Pro Q, which hopefully you're looking at the picture now, that is the most advanced milking machine in the world. It's a rotary. This particular one has got 72 robots on a rotary, and yeah, and I'll talk more about that when I talk about our product. So whether you're milking your cows with one of those, even though it is far more advanced, or you're milking your cows with one of these, I don't know where this came from, but it's a milking machine basically on the back of a donkey. The principles are exactly the same. And just out of interest, I thought I'd throw this in. So you can see a cow is usually, or a calf usually sucks the cow about every 4 to 6 hours. If you're milking a northern first seal, if you could catch it, that would be once a week. Going on to the milk production, just to show you what a cow actually does and needs to produce milk. I always find this quite fascinating myself. The average person needs 2,000 calories of energy a day. A 30-litre cow, or a cow producing 30 litres of milk, needs 80 megajoules of energy for maintenance of a body, plus 5 megajoules per litre to produce the milk. So just to jump straight to my next slide, a cow producing 30 litres of milk is like you running 22 marathons every single day. A lot of energy is used up by that cow. So cows do suffer from heat stress. When they're in the buildings, they need, if it's cold enough for you to put a coat on, that's probably the best temperature for a cow producing milk. They do need well ventilated barns. And if they're out in the fields and it's a hot sunny day, heat stress is a major problem. So the cow would rather be inside during those conditions, to be honest, rather than out in the sun. So it's just worth thinking, bearing that in mind. Going on to the anatomy of the udder, a very simplified version of an udder. So you've got the alveolar area at the top, then you've got the cistern, the teat cistern, and the teat canal. And in the alveolar area where we've got the alveolus, that is where the milk is mainly held. People always think that the milk, or the general public perhaps, think the milk is in the bottom of the cow in a big bag. That isn't the case. It's held high up in the udder, and that is worth bearing in mind. So the udder is made up of 4 separate glands. They're all independent from each other, so it's not just one big bag. But in terms of inflammations and that and treatments, if a cow has got an infection in a quarter and you do treat that quarter with antibiotics, obviously it could affect the other quarters. So you would dump the milk for the specified time before then you put it into the tank to be taken away for drinking purposes. The cow needs good blood supply going around the ovuli to produce the milk with various duct systems and that, and the bag is held up by a suspensory system. And obviously the bag of the cow can come in all sorts of different shapes. Again, just to let you know what the cow is actually doing to produce that milk, just for 1 litre of milk, she will need 500 litres of blood flowing through her body. And if you think a cow has got about 5 litres of blood in total, that blood is going around 500 times just to get 1 litre. So if she's a 32 litre cow or a 30 litre cow, that's a lot of blood being used to produce that milk. I won't read all the facts here, but just to go down to the bottom line, the depression of milk secretion, the FIL, feedback inhibitor of lactation. So people say, why do you milk a cow twice a day or 3 times a day or 4 times a day in some cases? When a cow has a calf and she starts to produce milk, in the milk there's this FIL, if you like, the feedback inhibitor of lactation. This protein in the milk tells her whether to produce more milk or not. If there's a lot of this protein in the milk, say the cow loses a calf for whatever reason, the calf dies, she's got this milk. If that milk is in her and it's got that protein in it, it's telling the brain to stop that cow from producing the milk because it's not needed. The more you milk a cow, the more you remove that inhibitor, so the more milk she'll produce. And that's why milking a cow 3 times a day instead of twice a day makes the cow produce more milk, providing obviously you feed her for that milk. She's got to get the energy somewhere to produce that milk. And it's certainly important to bear that in mind when we're milking with robots, and the importance of milking cows more frequently than twice a day. In terms of in the udder, like I said, most of the milk is stored up high in the udder and can't be milked directly. It's stored in the udder, and 20% might be in the cistern, come down into the cisterns in the lower part. And that decreases towards the end of her lactation. So a cow has a 305-day lactation on average. First 100 days, the milk goes up, and then it starts dropping off again. For her to produce the milk, the alveoli must contract and press the milk down into the lower part of the udder, so we can milk that cow. And there's one thing that does that, and that's oxytocin. Oxytocin is the most vital part of the milking process. It's also used in childbirth or calving and that, but from our point of view, extracting milk, oxytocin is very important when it comes to milking the cow, especially for the cow's health. If you see a cow leaking milk when she comes into the parlour, it doesn't necessarily mean that she's all the milk in the alveoli has started coming down. It just means she could be losing that milk a little bit in the bottom, but it doesn't mean to say she's not well stimulated. So to get the oxytocin flowing through the cow's body, and that comes out of the pituitary gland into the blood system and then into the alveoli, you need to stimulate that cow. And there's various ways of doing that, which I'll come on to in a minute. So stimulation of the udder, such as fore milking. So when the cow walks into a parlour, even like playing the radio and things like that, it sort of gets the cow calm and thinking about this. And then when you start washing her udder, that's when the alveoli start bringing the milk down into the lower cistern area. And it's crucial you do this. So you have to stimulate the udder first. And it then takes about 40 to 60 seconds for the oxytocin to start getting the to work to get the milk to come into the udder below. And that is quite crucial, because I'll come on to that in a moment, because if you don't get the milk coming down into the lower area and you start milking the cow, it can be painful for the cow, and that's the last thing we want. If a cow gets stressed, it's the fight or flight, I suppose you could call it. If a cow gets stressed, adrenaline is produced, and that immediately stops those oxytocin working, and that immediately stops her producing milk. So it's critical that that cow is calm and happy when she walks into the parlour. She's stimulated, the oxytocin starts producing the milk starts flowing, and then you can milk her quite happily. So, and that's a continuous action. It doesn't stop straight away. You need to be constantly stimulating that cow and keep her fairly calm and happy. To milk a cow, you need various things. A calf will suck a cow's teat at approximately 40 kPa, 40 kilopascals. So obviously, if you're milking a cow by hand, you squeeze the top of the teat and squeeze the milk out. Well, that isn't how a calf sucks the milk out of a cow. And what it's done by vacuum. And so we have a vacuum pump. So you'll need a vacuum pump producing a lot of vacuum. Then what we have in a parlour, you have a vacuum regulator. So this is basically a motor connected to a vacuum pump, and that'll produce, depending on how big the parlour is, 2,100 litres per minute of air. And then it's controlled by a vacuum regulator, which just sucks air into the system to keep it at a constant 40 kPa. We've now got another product called vacuum on demand, which is a frequency converter, which actually controls the speed of the motor to keep the vacuum at 40 kPa or 46, depending on the type of parlour. Before that, you were just sucking in air with this manual regulator, and the pumps were going full bore, wasting a lot of energy. Now we've got these frequency converters. If you're a farmer, if you've got 3-phase milking cows and you haven't got a vacuum on demand system, you need to speak to your manufacturer to get one, because that's the most cost-saving thing you can do when it comes to milking your cows, is to control the speed of these pumps. So that's a vacuum on demand. So you've got a vacuum, nice controlled vacuum. You've then got a milk line, either high line at 46 kPa, kilopascals, or 40 if you're milking low level. You then need that to go into a milk meter, into the milk line by putting the cluster on the cow, and you then need a pulsator to control the cluster, which I'll explain in a minute, and then just a milk meter to tell you what that cow is doing, a display. So I'll come on to the liner. So what you need here, you need, as soon as you put this unit on the cow, so you've wiped your cow, you've cleaned her, you've fore stripped her, so you've taken out a bit of the first milk, make sure the udder's healthy. You then, and I'm talking about conventional milking here. I'll explain how robots work in a bit. You've then got a liner which goes over the cow's teat, and it's in a shell. So vacuum is applied through here, and you've got 40 kPa sucking on the teat there, and that closes around the teat, and that's called the rest phase. That's the massage phase. That's not milking the cow. When this is sucking and this line is closed around the teat, that's what we call the rest phase. You then have the pulsator, which alternates pulsation between the two sides of the cluster, because you've got 4 shells in a cluster. Vacuum is applied through the short pulse tube, and that pulls this liner open. And when that liner opens, that's what's called the sucking phase or the milking phase. So as that liner opens, milk is then drawn out of the cow, down the long milk tube, into the milk line, and then into a receiver, and then it's pumped into the bulk tank. Or if she's got antibiotics, that goes to waste, obviously. So that's the simple milking philosophy behind how a cow is milked, is this opening and closing, depending on the manufacturer, around 62 pulses a minute. So just to move on, hope this is making sense. So there's the cluster on a cow's teat, and they're just opening and closing. That one's closed, massaging the teats, that side's opening. And they quite often call it the dancing cluster because it swings from side to side, and if it's milking a cow well. Over here on this side, it shows you a bit of a glass view of a line, a clear line, a clear shell there, showing how it's working. And here's the phase. This shows the vacuum starts to be applied. So the vacuum's constant through the short milk tube, but then vacuum is applied through the pulse tube to open up the liner. So this is the A phase, where the line is opening, then the length of the liner remains open for, and then you have the closing phase and then the closed phase. So that's the A, B, C, D phase, which is made up of E, the milking phase, and F, the massage phase when it's closed. So that's really the principles of how that works. What you need, though, is a smooth, non-aggressive milking. And I've put here GEA principles because this is a presentation that we use, but it'd be the same for most manufacturers. This is how you should milk a cow. Smooth, non-aggressive milking. High levels of comfort for the operator and the cows. Maintenance of good teat condition. You want the cow's teats to be good so they don't pick up bugs in a rough skin on their teats. We need healthy udders, low somatic cell counts, reliable, durable equipment, and then the technology then comes in to monitor and manage the milking process if we need to take things further. This is the one of the GEA vacuum pumps, very stable piece of equipment, very accurate. And this shows the milk line. You need big milk lines, so you've got milk in the bottom flowing one way and then vacuum flowing the other way. So the milk's flowing into the milk line, away from the milking cluster and into the receiver, and vacuum's heading the other way. So we like to work with low operating vacuums, stable plant vacuums. We use an alternating pulsation, like I mentioned earlier, where it swings from side to side, and we need to milk well stimulated cows. We use loop lines, so you've got vacuum heading both ways. So you've got a big line where the milk's collected right around the parlour that the milk flows into. This is a bit similar to what I've said before, so I shall move on a bit. This bit here, this is a GEA meter body that's been around actually since 1982. So reliable, so accurate. We still use it today in our robots. Very accurate piece of kit that the milk flows into, and then it measures the milk flowing through the milk meter to give us accurate IAgrE approved milk recordings. The pulsation, absolutely critical. Before it was systems with manual pulsation. Now obviously most things are of electronic pulsation, much more accurate, to give us much more accurate figures when it comes to the pulsation and milking that cow properly. As I've said earlier, you've got the A phase, B phase, C phase, D phase, and they are all quite critical, fully adjustable, but we tend to stick within certain boundaries, with a pulsation ratio of 64:36 on the milking versus the rest phase. but there are variable settings depending a lot on the liner. So when a manufacturer puts a parlour together, the liner being the only part that is one of the few things where an animal is actually touching a piece of machinery, it's critical that this detail is correct. Now, I'm not a technician, I'm a salesman. So if you've got any questions about this, please speak to one of our technicians. They'll know more than me, but I'm just trying to point out how critical this is when you want to milk a cow properly. We use a large claw. We've got various claws. I just put this one as an example. Typical cluster, the 300cc cluster, good milk flow out the cow, straight at the back of the cluster into the milk line and away. That's absolutely crucial. We got an Evo one. The modern cow now has her teats closer together at the back, so this now points up as opposed to across, so it sits nice on the cow, because how it sits on the cow is also critical to the milking of the cow. Average weight, and 70% of the weight is in the shells, so they're hanging nicely off the cow, and then the rest is in the claw base. Poor cluster alignment can create major problems with milking cows. We had a situation with a farmer that had his long milk tubes far too long, which also is an issue. You want as short tubes as possible. And we said to the farmer, why are you doing that? And he said, well, because I've got a heifer and she pushes up between the cows, she's hard to get the units on, stretching a long way. I've got long pipes so I can reach her. And we were saying, why would you sort of disrupt 99% of your cows just for that one cow? Put an extra bit of pipe in or something. It's absolutely crucial that you milk those cows properly. Cows nice to, it's again conventional parlour. This is a Euroclass 800. Cows positioned nicely with crank rump rails, so they all sit in the right place. So the milking of the cow, the cluster's held nicely through the cow. Stall work. So you either have a low level parlour like this one here, so the milk line's down here with a milk meter, a cluster taking the milk out of the cow, running down here through the milk meter into the milk line, or a high line. This is a swing over parlour, so you've got one unit between two cows, so you could be prepping one cow, stimulating one cow while you're got the unit attached to the other side. Then you take it off that cow and swing it over and put it on the other cow. That's the swing over parlour. It's a high line, so you have a slightly higher vacuum because you're pulling milk uphill, and I'll come on to that a bit more later. The pulsators don't work when a cow isn't being milked, so it's a lovely quiet environment. When you first turn the milking machine on, especially with the VO vacuum on demand, so the milk pumps are going, the vacuum pumps are going quite slowly. When you turn the units on, you don't even know the parlour's working. And then when you start putting on the cows, the pulsators kick in and then the cows start getting milked. If you want to know more, our technical manual tells you all about it anyway, and you get one of these when you buy our products, or you can just ask for a technical manual, and it tells you all the procedures of how to milk your cow. Most of the stuff I'm showing now is probably plagiarized from that. When you milk a cow, okay, so a milking can take say 7 minutes or so, or if she's 3 times a day, if you decide to milk her 3 times a day every 8 hours, then obviously it's less because she'll have less milk in her. But when you apply vacuum, as soon as the milk starts flowing, then the vacuum reduced. As soon as the milk stops flowing, then the vacuum goes back up to the 40 kPa or whatever set the parlour to. Right, this is the absolute crucial part of milking a cow about stimulation. If a cow walks into a parlour and she's not stimulated, she's not calm, she's not letting the milk down, what you will do is you'll start milking that cow. You put the unit on straight away, it starts milking that cow, it takes that 20% of milk out in the bottom of the bag in the cistern, and then there's no milk. That's when you start damaging your cow's teats, because it's milking away with no milk. Eventually, hopefully, she starts letting her milk down, so the alveoli start squeezing, the oxytocin kicks in, the milk flow then goes up, you start to milk it, then it drops off, and then it tails on a bit, and then there's a bit more milk. So we call that a bimodal milking, because she's milked first, she hasn't let her milk down, then she's milked again. We call that bimodal on the red line there. What you want is to get her well stimulated. So even if you start the actual process of stimulating first, wait a minute, then attach, you get this much more smoother curve, and you get a quicker milking, and there's less damage to the cow. What happens then is, if you start taking if the unit starts taking the cluster off after, depending if it's twice a day or 3 times a day in the setup of the parlor, it could be 300 grams a minute or 600 grams a minute, you can take it off much sooner if she's been stimulated better, because if you took it off here, there's less milk here than if it had been tailing on, and you took it off at a high level here. So this oxytocin is absolutely crucial to milking that cow, as is the setup of the parlor. There's a farmer. This is just a report from one of our systems, and you can see here that 2% of the cows haven't let their milk down properly, or a second milk let down. So as a farmer up in Yorkshire, which actually pays his staff bonuses on how well the cows let their milk down. The result is, if you don't set the parlor up right, don't milk the cows properly, is basically the cow, damage to the cow. And there's various examples here, which I won't go through, where it can affect the cow's teat. That will affect the quality of the milk, the Bacter scans, and the infections she gets. What I will quickly do then is talk about, I can see it's 12:31 now, quickly talk about the MEA. So the MEA is a Milking Equipment Association. And what I'm asking here is, do you want British customers to have the best quality milk with the best animal welfare? I'm going to fly through this. So the Milking Machine Manufacturers was originally called the Milking Equipment Association. And the idea of it is to promote, educate, and improve best practices and standards, influence relevant dairy organisations. So if there's any dairy organisations listening on this, this is the purpose of my presentation today. What the MEA is about, as far as I'm concerned, is bringing on young people to know how to operate and maintain the equipment. And so we've produced an accreditation process with Reece Heath College, and Harper Adams, with Mike and Ian doing CATS 1 and CAT 2, training people how to set those machines up properly. It doesn't matter who the manufacturer is. It's getting young people to learn how to set the machines up. It's all about cow welfare, milk quality, profitability, and the link to the Engineering Council for it. And the benefit of this, of doing this all properly, is for the cow, the farmer, the operator, consumers, dairy process retailers, and technicians. Who is in the MEA at the moment? 5 major players: Bomatic, Laval, Forward, GEA, Lely. So it's called Parlour Safe at the moment, the accreditation scheme, but we might change it to Milk Safe. And we got up to 100 associate members, with dealers and other people being part of it. And we're always looking for new members. The more people involved in how we look after the cow and the staff that can look after these machines, the better. If you think of a dairy technician, he's got to know the physiology of the cow as well as the psychology, principles of milking machines. He's got to know mechanics, electrics, electronics, refrigeration, pneumatics. Where do we get these people from, and how do we keep them? You might say with Brexit and that, we can't get people into milk cows, and let's all go with robots. Where do we get the people to look after these machines? We need to get these people trained. We need them to have accreditations of some sort, and we need to make them want to do this job. It's quite interesting. I was speaking to a farmer last week. If you think of a tractor and dealership, they seem to charge double what a dairy engineering dealership would charge per hour. And I don't understand that for the amount of work these guys have to do. Interesting picture of Zorro here. The reason I put this up, I had a hernia operation about 6 months ago. I actually went online to see if the surgeon that was operating on me was actually qualified. Obviously, with my company, I managed to go private, and they wouldn't take on anybody that wasn't qualified. But I wanted to know I had the right guy operating on me. Why would we want and the reason Zorro's in this picture, he might have done it with a sword, much quicker, much better, don't know, but he wouldn't be qualified. Why would we want somebody that isn't a qualified dairy technician working on our milking equipment to work on the milking equipment when he's not qualified. And that's why we need accredited people. And so this is a plea to milk buyers. Please ensure if you buy milk from your farmer, he's had an accredited engineer or technician, should I say, to work on that equipment. So yeah, that is why I'm asking, do we want the best quality milk with the best animal welfare? Any more interest in the MEA, just give us a shout and we can put you in touch. So just a quick about Farm Technologies, a bit of a plug for ourselves. We were known as Westfalia Surge, always owned by GEA, but so we've always been part of GEA, but now we're called GEA Farm Technologies as opposed to the Westfalia Surge. We've also bought Milfoss, Hall, Muller up. So we're a big company. We're also supporting, just a little note, to promote the farming community network or farming crisis network. There's a lot of farmers we speak to that, you know, have got problems and that, and if you know of anybody that you needs to talk to somebody, just bear in mind the farming community network. I was going to talk about GEA Farm Technologies. The most important people in our company is the staff. I'm just going to mention a few people because I was going to come on to robots, but I believe I've run out of time. If you're looking at putting in robots, speak to our guys. We've just taken on Andrew Kay, who's a large project manager. For any farm that's even thinking of milking cows, thinking about changing their milking equipment, come and talk to us. That's all I'll say on that one, I guess. We've got a dealer network for the whole country. So either speak to your GEA dealer or speak to us. The products we do, Dairy Pro Q, the machine I just mentioned earlier, robots, and automation isn't just down to robots. We've got Apollo for milking. We've got Cow Scout, and crucially, talk to us about planning. Planning is the most important thing, especially with robots, and then the herd management. The equipment comes, as far as I'm concerned, comes second, even though I believe we've got the best milking machine equipment in the world. Planning and herd management are extremely important, and we do a 5-year warranty and 0% finance. Bit of a plug there. And then I'm just going to fly through our products. Cow Scout, this recognizes when a cow becomes bulling or on heat, saves the farmer a lot of money trying to find out when his cow comes on heat. Yeah, so it's a heat detection and it's a health monitoring. If that cow goes sick, this strap around her neck will tell her she's sick before the farmer knows it. It monitors her eating. It also monitors her rumination. Plus, obviously, the best time to inseminate that cow. Apollo, dipping the cow afterwards. Normally, a person would manually dip the cow. Automation isn't just about robots. Like I said, there's an Apollo milking system which automatically dips a cow, and then it flushes the cluster afterwards. So it's a clean cluster on a cow, and there's a special valve in here. So when it dips a cow, it makes sure no iodine gets in that milk, because although iodine is naturally occurring in milk, you wouldn't want to add any extra iodine. And the cost of mastitis, as we know, is very expensive, one of the most expensive diseases to the dairy farmer. And then I won't talk to, if you want to see the best, most advanced milking machine in the world, come and talk to us, Dairy Pro Q, Michael Eavis, Glastonbury. He's got the one in the UK. There's 38 installed around the world. It's a modular design. I will just show you very the way one of our main advantages of this system. So automatically it goes onto the cow. Nobody puts it on. It washes the teat, so you don't have to wash or pre-wash the cow first. It then strips the teat. It stimulates the teat, and then it starts milking the cow, all in the liner. So it doesn't have to do these processes individually, and then it dips the cow. And I would just one last thing. Then we've got a cell count sensor here. This is quite new. When certainly some milk buyers are looking at dry cow therapy and selective dry cow therapy. So when a cow has finished milking, you can tube with antibiotics. Obviously, we're trying to avoid the use of antibiotics where we can. So where a cow has got a low cell count for the whole bag on a conventional milking parlour, you can decide whether you tube her or not, or just whether you seal off the teat and then she goes into the dry period. With this system, it can individually tell with our robot, whether it's a Dairy Pro Q or our R9500, it can tell individually if that cow's got a high cell count. So you could reduce your use of antibiotics by just tubing the one quarter, which might have a high cell count, and not the others. So it's a great way of reducing antibiotics. That's quite a new product. You could sample every quarter, I guess, but this thing is doing it every day at no extra cost. So that's a new product, fairly new product we've got, well worth considering. I won't talk about EVIS. And then what I will just one thing. If anybody's thinking about robots, what is UK average litres per robot? The average for all robots, for all manufacturers in the UK, is about 1,600 litres per robot. People keep talking about 2,000, 3,200 litres per robot. Yes, they can do that, but I could have a Ferrari and drive it 200 miles down the motorway, but if I'm going along country lanes, I certainly wouldn't be doing that speed. And it's worth talking to us if you are looking at robots about that sort of information. And then I will very quickly show you.
The attachment camera guides the milk rack from its parked position to the optimum attachment position. The camera locates the teats and cups for a fast and smooth connection. If the cluster is kicked off during attachment or the cows move, the camera readjusts and moves to reattach immediately. Once attached to the teat, the kick-off sensor is able to detect this and the inliner process begins.
And that's either attachment on a Dairy Pro Q or a robot using a time of flight camera. I'll skip that. Using a time of flight camera, looking at the teats and attaching using a camera. It also remembers the coordinates, so it gets faster and faster every time, but it can attach straight away just using the camera. And that is me done.
Okay, thank you, David. We have run over a little bit, but
yeah, sorry about that.
No, it's fine. It's really interesting, really good stuff.
Really
I think if people want to ask any questions, I think the best thing is to pop them in the chat, and we can deal with them separately or at the end if you want, and we can crack on with the next presentation if everybody's okay with that. But yeah, thank you for that. Really, really interesting. So the next presentation is from Daniel Bussmann. Daniel is a process engineer who started an apprenticeship as a dairy technician in a small German dairy, which was focused on organic products from drinking milk to yogurt. After finishing his apprenticeship, he went back into education and gained a BEng from Hanover University in dairy process technology. And after gaining his BEng, he joined GEA in the technical support area for separators in dairy and beverage. And then for the last couple of years, Daniel has headed that part of the business. So Daniel, if you'd like to start your presentation.
Yeah, I just wanted to give you a quick introduction in let's say the separators world, centrifugal world for the dairy application. Coming from the milking equipment, normally the next step is cooling it, to be honest, and then sending it to the dairy and processing it. I just have prepared also 2 slides showing you about GEA, nearly saying it doesn't go ahead. No, it's going ahead. Saying the same things as David already said before. We have some nice sheets showing what exactly we are responsible for in the world. So the chicken nugget thing, I think everyone is showing, was likely to show, and we also working in a lot of fields for the beverage applications like breweries and instant coffee applications, the beverage business and chemical business also. But today, as it was in the topic, we will focus on the dairy and the milk. And there we also involved in the whole process of finding the milk, processing it, and producing all the nice products we have in the world. It was a bit too fast. But today I will focus on showing you the main purpose of a separator in any dairy you will find in the world. So we have, from the technical background, a separator is a bowl of stainless steel rotating inside of a housing. You see it here that the inside of the separator is rotating, and we have a lot of we have a bowl which is rotating with approximately 4.5 to 1,000 RPM up to 10,000 RPM, depending on the bowl size, to create a high G-force. I will show you later why this is important. And inside of the separator, we have segments which supports the sedimentation of goods in the milk or in the product itself. For the dairy, we normally speak about skimming, so taking out the cream of the milk and clarifying the milk if there are non-milk particles you want to get out. So any separator consists of a distributor, which is just here, which is this part you see here. This distributor is then distributing the milk to the inside. Just going to the next slide. So which is then bringing the milk into the separator, bringing it up to speed. So also speeding up the milk to the same rotation speed the bowl has. And then the separation immediately starts of in that case, the cream and the skim milk. So the skim milk is the heavy phase, which has a density of approximately 1.04 gram per kilogram per liter. And the cream, which is going to the pushed to the inside of the separator with a lower density. And then we create a skim milk with a low fat content and a cream with a high fat content, and in the same way we separate big particles out of these of these products we have in there. So you can separate out dirt, dust, and somatic cells also. On the top we have a centrifugal pump which is pumping out the liquid phase out of the separator and bringing it to the next processing steps. In that case, we normally talk about pasteurizing the milk or pumping it to a storage tank or whatever the customer is talking about. Yeah, and the solids we collect on the outside and eject by intervals from time to time. So in the past, the system were working like a closed system. You were collecting the solids, and after production time of a few hours, you had to stop the separator. Someone had to come and to dismantle the machine and to had to clean it manually. And in the 60s to 70s, the separators were designed that they were able to do an ejection, so to open the outer diameter for a very short moment and eject the solids. The principle the separator is working on is mainly based on Stokes' law. So the sedimentation of particles and medias with the different densities. Where we with the separator have effectively one big point where we attack or where we get a crucial point. What we are doing is we speed up the product and in this case the milk in a range that we achieve G-force which is 10,000 to 14,000 the time of G-force you are facing every day. So the sedimentation of a cream in that case is then speeded up by that time in this. What we also do is we heat up the milk before separation to increase to increase the density differences between the medias and to reduce the viscosity. That's also supporting the separation. But the main effect we have in the separator is that we use the G-force we normally have on the Earth, which is 9.81 meter per second, and we replace it by the G-force created by the separator, which is a result of the rotation speed and the diameter of the bowl. And by that, we speed up the separation speed of the cream and also the separation of the particles in the product itself in the milk. additionally to that, we built in disc into the separator. This disc are plates which we place on a disc stack, we call it, with a very low gap in between. And this low gap in between is reducing the area the particles have to sediment to collect at one point. So you can say if you see it here, the yellow parts are the cream and the gray parts are the non-cream particles. They had to get in touch with one of the inner outer diameters. And by placing a lot of disc on a disc stack, we are reducing the space they have to travel. So an example, if you normally would feed into the system, the cream had to go the way I show you here with the graph. And by installing a disc stack, you reduce this heavily by a lot of lower numbers. In an industrial system, the disc stack has a distance between all the discs of 0.25 millimeters. So you can imagine that in a separator, which is doing, let's say, a dairy application with 60 cubic meters an hour for skimming, we have 400 of these plates in one disc stack. So we increasing the area the cream can settle, and we decreasing the way the cream has to go to connect the discs, and then we also rotate quite fast to increase the sedimentation speed of the system and the milk. So light phase is going to the inside, which is in the dairy application, the cream, and the solids and the skim milk are going to the outside. And normally we say the solids we're separating have a tremendously higher density than the skim milk, and they go to the fully outside of the separator, and we collect them on the solid holding space, we call it. So here are collected all the non-milk particles, you can say. So an example, the somatic cells, if the milking equipment was not 100% fitting to the cow, or if the milk if the person in the using that milking equipment was milking too long, the number of somatic cells is increasing. That's something the dairies heavily want to avoid due to misflavors and all these things. And also you see from time to time, you see dirt coming, some dirt from the cow, from the udder into the milk. And that we separate in the separator, collected on the outside and ejected in intervals from time to time. And these ejection is a very short moment of the processing time. So we open the bowl on the outside for nearly 100 milliseconds. And in these 100 milliseconds, we eject approximately 20 liters, up to 20 liters of solids out of the bowl. And you might imagine that volume in such a short time is creating a lot of turbulences inside of the separator. And you hear that if you have a separator ejecting, we call it normally a shot, because it sounds like someone is shooting, you can say. And we have some special separators mainly used in beverage applications, which are reducing the ejection time from 100 milliseconds to down to 20 milliseconds. And there you really hear the noise. It's a very high, very heavy noise, which is coming from the separator, and sometimes you get a bit respect out of that. Yeah. Nevertheless, the system is a very safe system. So if ejection is done, it's closing directly, and the separator doesn't have to be stopped. It's just running ahead and going in the processing ahead and skimming and separating what it should do. The liquid is transported out of the separator bowl by a centrifugal pump, we call it. So in the end, it's nothing less than the reversed working mode of a normal centrifugal pump. We just have these part stands still in the liquid, and due to the rotation speed, the liquid is rotating and pushed into channels, and by that we change the rotation speed of the liquid, and the G-force we have and the energy in the liquid we change into pumping energy. And we can pump out the liquid with a certain pressure out of the separator, and normally process it then without having any additional pump in the system or something like that. So what are the separators normally used for as a standard application in a dairy? So what we sometimes see are clarifiers in a dairy. That's mainly done when you have lower quality of milk, which I would say is not the Western standard. But if you go to Africa or India or South America, where you sometimes have milk of lower quality or a lot more dirt into the milk, we tend to install clarifier before our other separators to avoid blockages to make the process smoother. We have skimming separators, which have the main task of getting out the cream from the milk and producing blank skim milk and as high as possible cream normally. And we have a bacterial remover, which is supporting normally the step of heating the milk, and especially in cheese plants to avoid low early and late blowing of cheese in the processing, and especially in the ripening of the cheese, which is one of the big risks, or was one of the big risks in the past, where we have the possibility to get rid with our bacterial removers. And technically, the only really necessary system in a dairy today is a skimming separator, which is normally placed into a plate heat exchange or in a pasteurizer system, where we have to normally heat up the milk to a certain type of temperature, depending on local regulations. But normally you say that we have to go higher to higher than 72.5 degrees to inactivate all the microbiological things which are bad for the human living, just say it like that. And also we then use the temperature we have in before to make the skimming and produce a skim milk with a low fat content and a cream, and then also do the standardizing. So if you get the milk with 1.5% fat or 2% fat or whatever our customer is producing in that way, we can achieve with our standardizing unit, adjust the milk and then going to the next processing steps. But we also see a lot bacterial removers in this process coming up from the past, mainly used in cheese factories to avoid these ripening failures like early and late blowing, and also misflavors in the taste. But also you see the Prolong here also coming up, that we have a two-step bacterial removing separation to increase the shelf life of a drinking milk or any milk product they have in the dairy. So just from the principle, again, what we have is a clarifier. So this clarifier only separates two phases. It separates a clarified milk from solids, so that we get a nearly solid-free milk. We also use it a lot in, or we use it more in whey and let's say milk processing steps from the later fining steps. So it's one of the main tasks for clarifier is the processing of whey, to clear the way that we can later then process it, skim it, and that the customers can produce a concentrated whey protein or whatever is then needed from their side. Just give me a second. Was date. The most important and main step in all the task is the skimming of the milk. So to reduce the fat content in the milk and create a cream which has a certain fat content in the end. We normally say that we can go down to a value of lower than 0.06% of fat in the milk. This is mainly influenced by how hard it is pumped. So in the end, we want to have a milk which is experience as low possible shear force as possible, that we have the best separation effect possible. Nevertheless, we know that the value of 0.06% of fat in the skim milk is one of the borders where we normally have, which we normally have in skimming of a that we in Western Europe, we use a lot of the traditional cows, the traditional cattle for producing milk in Western or in India, Southeast Asia, and all these countries. They have a lot of buffaloes and all these things, and the type of fat they produce is a bit different. So these values are changeable, let's say it like that. As I mentioned, also the skimming separator is doing some particle sedimentation, not as good as a clarifier, but it's also doing that. So that's the typical thing every separator is doing, and also ejecting it from time to time. Bacterial remover. So this one is normally then bacterial removing skim or standardized milk. So we feed it to the system and we create a heavy phase, which is a concentrate from bacteria, and we have a sedimentation of these bacteria on the outside of the separator and eject them by time to time. What specialty we have with our bacterial removers is that we have a recirculation of a heavy phase, which is a concentrate of these bacteria, and give them the time to have a sedimentation the next time they pass through the separator. This is nowadays standard. In the past, it was a unique system from GEA, but it has shown that the effect of that is quite tremendous one, and we are able to reduce the spore content up to 98% from the feed numbers. This is due to the very high density a spore has when they go to the separator, because they have a very hard and thick intern from the bacteria, and this is creating a high density. We also reducing the total plate count, so the total numbers of bacteria in the milk, but this effect is less than the spore reduction. And as I mentioned, it's traditionally it's used to avoid early or late blowing and cheese failures. In the recent year, it also was installed in dairy plants to increase the shelf life of drinking milk or any product they have without using additional heat, because additional heat is creating a misflavor in the milk later on, and the dairies still have the target to produce a milk which is as close as possible to the raw milk taste. Even no one in the world which is known to normal drinking milk and never tasted a raw milk will drink a raw milk from the taste, but they have the target to get as close as possible to that. And for that, we have our so-called Prolong system, where we use 2 bacterial removers to reduce the number of bacteria with each steps. And by that, we are able to achieve a shelf life, which is, let's say, in an area of 20 days, which was a standard pasteurization, where we normally would achieve 8 to 10 days. without any additional heating. And this is an effect we actively can show, and where we see that customers are really enjoying the good flavor of the milk produced by that. Nevertheless, my time also is running out, but I'm on my last page now. What I've shown you is the main processing steps we have in a dairy. In processing milk and drinking milk, let's say what I was just showing were the applications where we as Westfalia are already working or still working on, even if we do not talk about the standard applications of separator in a dairy, but we also work on the fresh cheese separation, on butter oil, on the processing of casein, so concentrating of the protein in the end, the butter churning, whey processing, lactose separation, where we, together with the casein processing, use decanters, so a slightly different type of separator you can use, the cream concentration, and in the end, also the so-called dairy alternative processing, where I have to say that from my background as a dairy technician and coming from dairy where everything was doing in a hand job, it was a bit, my heart is bleeding all the time when we get more active in that, but that business started to boom the last years, and we are also having some part in that. So yeah. If you want to have further information on that and on the things I showed you in my presentation, please feel free to contact me and give me any feedback. I would then support you with your questions, and yeah, that's it from my side.
Thank you, Daniel. I actually have a question. So the bacterial remover you presented, could you use that as a substitution for the heat treatment, like the pasteurizing afterwards, or the UH heat treatment, or?
Yeah, just to say, it's not as a full substitution. I just want, we use it as an additive to a standard pasteurization step. So what we cannot really ensure is that we have any type of bacteria which is unhealthy, that we can separate it out. That's the main problem. So you still have to do a heat treatment to inactivate these bacteria. So a standard pasteurization in combination with our two-step bacteria removing is a working principle to have a long shelf life and a drinkable product. If you would not do the heating step, you would have to name it as a raw milk still. Yeah.
Okay.
I have got a similar question off the back of Paul's question, actually, to David. Is that with robot milking, if you take the UK and Europe, what is the trend in the marketplace at the moment? Because obviously robotic milking's been around for sort of 3 decades now, but it's not had sort of widespread adoption. I just wondered what the sort of stats look like in terms of, you know, are dairy herds getting bigger, or more people adopting robotic milking?
Yeah, so in terms of, if you think in terms of money spent on milking machines in the UK, and we have to take a rough figure, as part of the MEA, we sort of know what's been spent. Obviously, we don't discuss value or anything like that, but we know. And so it's, if you take a rough figure of 50 million is spent on new equipment every year. Some years it actually 2020, we had the figures, is actually down 36%, to be honest. So there has been a drop in 2020 because 2019 there was a lot more robots sold on the basis of grants that came through in 2018. So 2018 there were a lot of grants, a lot of robots sold, which came through on the back into 2019. It was down again this year, 2020 a little bit, and this year they're talking about grants happening perhaps in October. Therefore, talking about grants in October. So my thinking is, I would imagine if I was a farmer and there was a possible 40% grant on a robot, I would probably wait, which means it will then be probably 2021 when it'll come up again. So it can be very, very reliant on grants. And obviously, if you look at the graph showing the milk price against plant sales, they are exactly in line with each other, which is strange because obviously investment of a milking equipment robot or milking equipment is over a 10-year or whatever you base it on, but the actual the graphs follow each other exactly. I'm not sure if that answers your question, to be honest.
Yeah, I suppose it's really just trying to understand, is it increasing? I can understand that, it's very grant dependent. Yeah, it
is, but it is increasing. It's growing all the time. So it's around about 54% of milking of the spend as far as we can work out, and it will grow. Especially, I think I was trying to point out in my presentation, yes, it's hard to get people to milk your cows now. It's a shame, really, because if you go into a big town, a big block of flats, everybody in that block of flats could be a brilliant person who love cows and milk cows. It's just getting to tell people that. When we get new people into the office, they work in the office, brilliant team in the office. They don't need to know anything about milking cows, but I'll take every one of them out on a farm. They'll milk the cows and they love it. So how do we get people into this business? It's so with robots, you don't need as many people. To be honest, the labor, you don't have to milk the cows, which is the drudgery, I suppose, but you still need the labor. 80% of your time is spent, as you know, with your 20% of your special needs cows. So you still have to put that labor into. You're still managing a herd of cows. That doesn't disappear. So the labor thing is perhaps driving robots. And my point is, yes, but we need technicians to look after those robots, and that's what we seriously need to look at as a total, manufacturers of milking machines.
I think you struck a key point there, that our industry, the agricultural industry in general, isn't so great at making itself visible to people. And what a great industry it is. And you're being very specific about the dairy industry there, but I think the agricultural industry as a whole is a bit like that. But it's a great industry to be part of. It
is, and people just don't know about it. So how do we tell people?
I know. The world's biggest secret.
Yes, definitely.
We're trying.
Okay.
Daniel, I got a question.
Any more questions?
I got one indirectly sent to me. What is the capacity range of these separators, and how long can you run them for?
Capacity range is the lower range normally is actually set to a value of 3,000 liters on our separators. You will find alternatives on the market which are not fully automatic, self-ejecting. But the nominal good running range start at 5,000 liters, 3 to 5,000 liters, and is going up to 60 to 65,000 liters depending on the process you run there. And the runtime of the separator is not exactly limited. Normally, our runtime is limited by the pasteurizing unit running together with the separator, because on the plate heat exchanger, you normally experience some fouling on the plate by temperature, and then you have to clean it. In the past, it was said that you normally would do it after 8 hours, but due to developments in the last years, the dairies already go to a cleaning step every 4 to 6 hours nowadays to ensure that their milk in the end has the needed quality. Yeah. So the separator can run 20 hours without a cleaning or something like that.
Oh, okay, thank you. Charlie, did you got any questions in?
No, I think we probably better draw it to a close. We've overrun quite a bit, but two great presentations. Thank you very much.
If I would be allowed, I would still have one more question from David, just out of curiosity, about the cell count sensor. If you allow me, Charlie.
Yeah.
Okay. You know the cell count sensor you presented, the M6850. Is it a pure total viable count, or can you also distinguish between different types of bacteria or pathogens in there?
No, so sorry, Daniel. Yeah, no, it's purely gives you an overall figure. So if you look at the a cow's general cell count, it can be a certain figure, but if you look at it by quarter, those differences are much greater. So it's giving you more insight into each individual quarter, and it's done in groups of 0 to 250, 250 to 500, 5. So it's not actually looking at the bacteria itself. It's more of a conductivity type setup. It doesn't need an agent, a reaction agent, to make it work. It's a complete flow through. So there's no cost involved once you've got it. It's just does it through the electronics.
Okay, thank you. Yeah, I just got curious, hence my question. Okay, Charlie, I'm done.
Okay, we'll draw it to a close then.
Oh, hang on, there's one more question coming in. People are waiting. Jeffrey is asking, hi, this is for David. So what material is the GEA inliner Teat stimulator made of?
So the stimulation on the robots, it's automatic stimulating, depending when it can see the cow starting to let the milk down, the oxytocin working, and we either use black rubber or silicon liners. In the UK, to be honest, I'd say we want to go more down the silicon route in terms of environmental reasons, I guess, but it's probably about 15 to 20% at the moment in the UK silicon. There's new laws coming in about carbon black, which come into effect shortly, and that's something we are going to have to look at. How, because apparently we're all going to die of carbon black now, so we've got to look at that and reduce that. So silicon might grow more over conventional rubber.